Hello YouTubers, welcome to part 9 of making our bow and arrow controller. This is the final part of this series. So here is what we will complete today in this video. So we'll almost finish setting up our controller and some final touches. And now let's see table of content for more better understanding. So we will try to create a crosshair, add realistic head reactions with our environment, adding our hip reactions that will align with our shooting, and also make our player react to environment, and then finally fixing some bugs. So the prerequisite for this video are my video on rotating bones to objects. Well, this is completely optional because this will be an alternative approach for the hip movement. Anyways, it's better to have some extra knowledge if you wish. Alright, so in the previous recap, the last video we created the word, added hit and laser objects, scripted the logic and placed them in the scene. If you did not watch my previous video, then please go ahead and watch it before going further to have some better understanding. And so if you want to have more of the stuff and a high controller, please go ahead and support me via buying the base or advanced version of this controller so that you get both code as well as a proper controller with advanced testing that's done by me. And also the advanced version has some extra features, so you can just go ahead and check out the GitHub page along with the itch.io for more proper documentation. Also, there is a dedicated video on the controller, so if you buy it, then you can also watch the video on how to set up. Anyways, if you want to support me, then you can do it via buying that. Now let's add crosshair for our controller. And yeah, the crosshair was meant to be added before actually shooting our arrows, and no issues, we will just do it now. So for that, let's create a new 3D scene with the root node as the control node. And now let's add a color rectangle, and let's place this rectangle at the center of our screen. And we can also scale this rectangle down. And this is not a rectangle, this is a square. And now we need to properly scale this rectangle with a box shape. So you can just press Alt and Shift together with scaling this rectangle so that it always makes a square. Okay, and I think the color rectangle is too small, so let's slightly make it bigger. Okay, this looks fine. And now let's also change the color to be a red one. So cool. And let's save our scene, and we will save the scene in scenes, and let's call it as crosshair. Okay, let's go to our player controller, and here we will add a control node, and let's make it as a full rectangle. So this control node will contain all our 2D stuff. So here let's add our crosshair as the child of control node, and now our crosshair is visible. So let's rename this to crosshair, and let's also create the reference for our crosshair in our root script. Now we want our crosshair to be visible only when our player is in the active state, and we want it to be invisible whenever the player is in inactive state. So for that, in the inactive script, whenever we try to enter this state, we can just call agent crosshair dot visible to false, so that the crosshair is not visible. And just make sure you spell the crosshair variable correctly. And whenever we enter our active state, we can just make our crosshair to be visible, and initially the crosshair will be invisible so that our player will be in the inactive state, so the crosshair should be invisible. Now let's check. So the crosshair is invisible, and let's go to active state. The crosshair is visible. Let's try to shoot that hit target. And everything is working as expected. And also, if we try to shoot far away objects, the arrow will have some drop, so you can see that the arrow does not hit that exact corner, and it has some drops and it hits somewhere over there. Cool. Let's change our state now, and yes, the crosshair becomes invisible. Okay, and let's also check whether this console prints our hit player, and yes, in the bottom you can see that the laser is working fine. Okay, now it's time to add some final touch for our player. So the first thing we will do is make our player head turn realistic. So in the characters, whenever you try to move around the world, you'll see that the characters try to rotate their head. So in our case, the character is looking very still, so he's always facing in the forward direction, and we don't want that. What we want is, we want our player to turn his head in whichever direction our camera is trying to look, so that it feels a kind of natural and also make our controller engaging. So for that, in the skeleton, we can add a look at modifier, and this look at modifier will be responsible for rotating our player's head to any of the point that our camera sees. And now, how do we make this bone to detect that what our camera is seeing? And for that, we can add a mesh instance as the child of camera 3D. So let's first add the mesh instance, and let's assign a box mesh. Let's make it small, maybe 0.1, and let's just move it here. So now this mesh will act as the point where our camera is seeing, and whenever we try to rotate our camera, even this mesh will be rotated along with the camera, and the player will try to look at this mesh, and this will create kind of effect where our player looks more alive. So let's quickly check it out. So for that, let's first rename this modifier to be head, and here we need to assign our target node, so which node we want to focus, and the node will be the mesh instance that we created, that was a child of camera 3D. And now we need to specify the bone name that we want to modify. So in our case, it will be our neck, and now the player is looking in another direction, and let's quickly solve that by going in the animation tree, making our inactive to be running, or let's just select our walk. So as soon as we select our walk animation, you can see that the player is now looking at the box. So let's try to move the box, and you can see the player is rotating his head along with the box, whichever position it's actually being. And now if we try to rotate it backside of our player, then you can see that there is some kind of devil that's going on with our player. So fix this so that our player does not rotate his head towards back. We actually need to clamp the rotation of our head. So for that, we can use this option that's known as angle limitation. So there is some limitation of angle to which our head can actually rotate, and here the primary angle, let it be 110, and also the secondary angle same as 110. So now you can see that the player does not rotate his head all along the back of our player. So let's now check this out, and as soon as this goes back of our player, you see the player has some limitations of clamping. And now we don't want our player's head to just make these sudden rotations. We want a smoother rotation so that this head feels again natural, because this looks very unnatural. So for that we can use this time-based interpolation so that our bone rotates slowly towards our target. So let's change the duration to be 1 second, and also the transition type, we don't want our head to rotate in a linear way, because if it's set to linear, then again the rotation will feel kind of ghost. So we'll use the transition type to be quart and the ease type to be out. And now let's check. You can see this feels a kind of natural. Okay, and you can try to use these different types of transitions that you like, also this easing type as you like, but I think the quart and out are fine for me. So now let's just place this box in front of our camera somewhere over here. Let's also place it down. Okay, so now whenever our camera tries to rotate, even this mesh will be rotating along with our camera. That's because our mesh is direct child of camera, and we can try to hide this mesh so that we can't actually see this mesh, but it will exist in our world and our player will be rotating towards that. Cool. Now there is one more option, and that's basically this influence and active in our head node. So what does this influence do? Well, if we want to set our player to rotate towards the mesh, then we set our influence to 1, and if you don't want our player to rotate towards the mesh, then we can just set this influence to 0. And now you may think like, hey, why do we need this? And the answer again is like, whenever we try to go in an active state, so let's say standing idle, you can see the player is trying to look somewhere else and the actual mesh box is at this point, so the player is looking somewhere else. So to fix that, we will only activate our head bone whenever our player is in inactive state, and whenever he tries to move away from the inactive, we will just set this influence to 0 gradually, so that there will be a proper transition of our head. Okay, and this active basically means whether we need to set the rotation of our head or not. Okay, so now similar to our head rotation, we also want our player to rotate from our spine bone. And why do I say that? Well, that's because if we run our scene, if we try to go in active state and try to shoot our arrow, you can see that the player is just looking at one direction and he's not actually trying to rotate along with the camera. So this looks like the player is looking somewhere else and the arrow will be shooting at upper direction. And whenever we try to shoot it lower, you can see that the player is not actually facing at the point where we want to shoot. He's just looking somewhere else without even a rotation of the hip. So we want our player to rotate to the direction where we are actually facing, and whenever we try to shoot the arrow feels more natural. So for that, we need to add one more look at modifier that will be responsible to change the rotation of our hip, and also we'll be just setting our head to be inactive. And now let's add one more skeleton, or I think it was look at modifier, and let's rename this to hip. Now let's assign the same target node that was for our head. So we will assign the same mesh instance node that was under the camera. And now why do we assign the same node? Well, that's because we want our player to rotate at the angle where exactly our camera will be seeing, and this mesh instance really helps us to have that kind of effect. So this mesh will be rotating along with the camera, and we can just rotate our head as well as our hip along with the camera. So we'll just target our mesh instance. Okay, and now the bone name that we need to target is Mixamo rig spine. So we want our bone spine to get affected, and the forward axis will be plus X, so that our player is properly rotated. And then we have this origin settings. Well, what does this do? So our spine bone will be somewhere over here, and our this mesh instance is up from our spine bone, and this will cause the player to rotate slightly tilted backward, so that our spine bone can exactly see where our mesh instance is, and we don't want that. So whenever our player is in a normal condition, or I mean that we don't want our player's spine to rotate, so at that time we want this spine bone to be exactly forward, and whenever the player looks up, so we want our spine bone to rotate at that time rather than rotating it at an inactive point. So for that, this origin settings really help us. And what does this do? Well, we can set a point from which we want our spine to look at. So for an example, we can just set a point to be somewhere over here, so similar to the bone that we had for our head. And here, whenever we are in a normal state, that means we don't want to rotate our spine a lot. And whenever we see upward, so that our camera goes down and the mesh instance goes at that point, then we need to slightly rotate our spine based on the angle of the head bone. And if you don't get that, then what I can try to explain is, let's just see what does this setting a different origin value do. So we will use a specific bone as the origin point, and the bone name will be the same as that we had, head to top end, and this makes a proper rotation, so you can see the difference. And here in the time based interpolation, we can set 1 second, or maybe a duration less than that, so maybe 0.7, and you can change this linear as you wish, but default settings are fine for this. And now let's try to check, and you can see the player is rotating wherever our camera is trying to see. Okay, cool. So now we don't want our hip to be active whenever our player is in inactive mode, and we want our head to be active, so whenever our player is in this inactive state. So the hip modifier will only get active whenever he tries to go to a different state. So we want these both to work alternatively along with our states. So for that, in our root script, we will create a function. So the function that we will be creating is, let's go down, and here let's write toggle hip head, and in this function we want to actually change this influence value. So for that, at the beginning, let's again create the reference for both of our nodes. Okay, so we have the variable called hip and head. That's basically having the reference for the respected nodes. And now in this toggle hip head function, we actually get our head value and also our hip value. So if you want to set our hip value to 0, then we get the argument, and similarly we also get our head value. And now we actually need to create a tween so that we have a smooth transition. So for that, let's again go to top and let's create a variable called tween of type tween. Okay, so we use tweens a lot to have a gradual smooth transitions wherever we want. So now here, if is instance valid tween, so if our tween is working, so which means that we just set our hip and head value, and these values did not actually finish, and again we call the same function once again. So at that time we don't want our tweens to have clashes. So what we basically do is we check if our tween is valid. So if it's valid, then we just kill our tween so that there is no clashes. And now we set our head to be active. We also set our hip to be active. And why do we do that? Well, that's because we'll be having some gradual movements. So if it's from 0 to 1 or 1 to 0, we need both of these to be active. We'll just turn off them whenever there is a requirement in which we set our influence to 0. But before that, we need to set both of these active so that we can see the real transition between these nodes. And now let's create our tween, call get tree, create tween, and here we can specify our transition type to be linear, and we set our parallel to be true, even though by default it's true. Next, we need to change these values, so we call our tween property method, and here we need to change the value inside our head node. And what do we need to change? Well, we need to change the influence value, and the value that we need to change for our head is our two value that we specify in our function. So if you specify our the head value to be 1, then the gradual change will be go from 0 to 1, and if we specify it as 0, then it goes from 1 to 0 with the time that we specify as 0.3 seconds. And we want to have this same transition for our hip as well. So we just change our hip influence value to the value that we specify with the duration of 0.3 seconds. And now if our transition has occurred, we can just trigger a function, and the function that we write is if the head value is equal to 0, that means we can set our head to be inactive. If our hip value is equal to 0, then we just set our hip to be inactive. So whenever there is any value 0, either it's for head or hip, we just set those modifiers to disable. And so we can also try to create a block of code like this. So this kind of structure you have mainly seen in JavaScripts, and we can also do that in Godot. So whenever our tween gets finished, we can connect to a function, and we just don't specify the function name, we just create a function, and then inside that we can write the block of code as this. Okay, now we need to call this toggle hip head function at wherever points we want to change our hip and head value. So the first place where we need to change is inside our inactive state. So whenever we enter our inactive state, we just call this function, and the first value that we need to pass is our head value. So whenever we are in the inactive state, we want our head to behave kind of natural, and we don't want our hip to have any effect. So for the head value, we set it as 1, and for hip we set it as 0. Then whenever we go to our false state, so whenever we enter here, we can just call agent toggle hip head, and here we need to set both of these values as 0. So whenever we are trying to fall, we don't want our head to have some effect. Also, we don't want our hip to have effect whenever we are trying to fall. And then whenever we go to aim state, here we call our toggle hip head function, and we want our head value to be 0, but we want our player to rotate to the direction where we are trying to shoot. And next, whenever we go to our active state, we don't want our player to rotate either our hip or our head. So we don't want our player to have the head effect. Also, we don't want our player to have this hip effect, so that wherever the camera is seeing, no matter what, our player will be in a proper position. And also, we need to copy this same stuff whenever we try to dodge. So whenever we dodge, we want to reset both of these so that our player will have a proper animation that's playing. Okay, it's time to check now, and we get an error. Well, that's non-existing function toggle hip head. Why is that? Okay, I just reversed this name in all of these functions. So let's just change the name as toggle head hip. Either you can just go ahead and change all of these functions name, or we can just change it here. Okay, let's try and run now. You see the player is properly seeing at the point where we are trying to go on our camera, and you can see that whenever we go in the active state, our player makes this rotation of his hip, and whenever we shoot our arrow, after the arrow has been shot, the player goes to his original state. And let's also make this mesh invisible, and let's also slightly make our mesh to the right side. So I think you can slightly make it here. Okay, now we can exactly see what our player is doing. And whenever we try to move, everything is working as expected. I just feel a lot of fun playing with these targets. Okay, you can also change this position to a little bit right of our player, so this will just create the effect and how you want it to behave. Also, at initially, let's just disable both of these. Now let's add the last feature of this complete series, and that's basically player reacting to the hits caused from environment such as laser or any other objects that you may create. So for that, first let's just hide our mesh instance node, and in the root script we will create the function. So let's create the function, call it as get hit, and remember that this get hit function is universal, so it will not be integrated with our substates. So the player can get hit from the environment in any of the state rather than a specific state. So we create this function in our root script, and here we need to actually trigger this transition node, as well as we need to trigger our one shot node. So to trigger it, we can call the helper functions that we created inside our animation tree, and the function to set our one shot active was this one, and here we need to pass this value, so which one shot we need to turn on, and then we need to trigger this react in this transition node. So for that, if we go inside our animation tree, let's search for transition and we have a lot of functions for transitions. So like some nested transitions inside our substates, and then we also have these transitions at our blend tree. We also have transitions inside these states. So let's see which transition we need to use. And yes, this is the function name that actually gets our active. I think not this, because it's going in active and then again the path, so this is not the function. I think this one is the correct function. So it's in the parameters, active, then the path. So the path basically gets this node, and then the transition request with the value. So we will use this function. And yes, it's kind of confusing, so that we have a lot of transitions. Anyways, in our animation tree, we use this set transition value, and the first parameter it requires is the name of the node, and the second is the name of our transition, so that's react. Okay, now we have set our one shot to be active. We also set our transition of react, but here the main problem is that we will not always be in this active state. So let's say an example that we were trying to move, and suddenly the laser tries to hit, or any of the enemy tries to hit us, and we need to play our react animation. And how do we do that? Because currently we were in our inactive state and we needed to transition to our active state. Or let's say that we were in our aim state. So we were in our aim state from this limbo state manager, and we need to play this react animation so that the player shoots his arrow and he tries to play the react animation. And how do we do that? So let's create a different function to check in which function we are currently in. So let's call it as check current, and here we will get the state value that we are in. So let's create a variable current state that will get our current state, and this is the function that we created above. So we get the state value, and now once we get our state, we need to get its name. And if our current state is not equal to active, that means either we are in our inactive, fall, or in the aim state. So if we are in a different state, then we need to transition to our active state. So we call our change state function, and here we pass our current state, and the state that we need to travel will be to active, and this is the event name that we specify. So we can go from inactive to active, we can go from aim to active whenever we call this event. We also go from fall to active. So Yes, this is correct. So now we need to call this get hit function from our laser. So whenever our player enters the laser, so at that time we need to instead of printing the statement such as hit the player, we need to call our get hit function of the player. So what this basically get hit do is uh, get hit tries to play the react animation, and here before actually playing the react animation we need to actually first transition to our active state. So let's say if we were in a different state such as inactive, then first we need to travel to our active state, only then we can play our react animation. So let's call this check current before actually playing the react animation. So if we're in a different state that's not equivalent to active, then we first change the state and then we start play the react animation. All right, so let's uh, place the player near the lasers and let's try to run the scene now, and let's go towards these lasers, and the glitch starts. Well, what is this? So the player keeps on playing the same equip animations, and we don't want that. We want to actually start playing the react animation whenever the laser hits. So here what happens is like, so if the player is in the inactive state, then so he plays this long animation maybe of duration 2 seconds, and then he switches to active state, but no, he doesn't switch to active state, but still he plays this equip animation. So we don't want that. What we basically want is like, whenever the laser tries to hit our player, we need to suddenly play the react animation of our player. So how do we do that? So how do we actually skip this animation? And to skip this animation, we can use this transition. So if you select the transition, then in the switch you will see that the switch mode is set to at end, which means that after playing this animation, only then we need to switch to our active, and only then we can play these animations. So we don't want that. Whenever our player enters the laser and the laser hits our player, we need to change this switch mode to immediate, so that there is a immediate transition from this state to this state, and whenever there is an immediate transition, the player can actually play the react animation. So how do we do that? How do we change the transition of this graph? So we don't want a transition from this to this at end, we want an immediate transition. And how do we do that? Well, this is a kind of new problem that we are facing, because in the previous videos, in the video where I have explained on how to control the animation tree from GD script, in that case we didn't deal with these kind of problems. So this is a new one, so let's start doing that. So here first we need to get this transition, and then we need to set its switch mode. So the question arises, how do we get this exact transition? What if we try to get this transition and we get any of the other transitions? So let me just quickly show you the docs. So node transition, so yes, I think this is the one. Let's see if it has switch mode, switc. Nope. So let's search the switch mode, and yes, the name is animation node state machine transition. So there is a lot of confusion between this and this. All right, so let's open it up and let's search for switch mode. Yes, it has like switch mode, curve, time, priority, and all the stuff that's listed over here. So how do we actually get a animation node state machine transition? So for this, let's again search for docs. How do we get, so this state machine transition is a part of state machine. So let's search for animation node state machine. So let's try with this. So yes, you can see that we can get a transition. So the function of this state machine, so that's basically this one, has a function called get transition that returns our animation node state machine transition, in which we can set our switch mode. So let's again open the doc. So here, to call this function, we actually need an index. So what is an index? So index is the value of the transition. So in this case we have like 1 2 3 4 5 6 7 8 and 9, so total 9 transitions. So we'll have each index for a particular transition. So now the problem again arises is like, hey, so how do we get the index value of this transition? Because there is nowhere listed that the index value of this transition is this particular value. So if there is no listed, then how do we get that? So once we get the index value, only then we can try to change and do the other stuff. And how do we get that? Well, just write the code that I will show you now, and I will explain it later. So here, so now what this function basically do is we print all the transition values. So in this case we will have 9 transition values. So first we get the tree root, and then we get the state machine of that. So the tree root is basically the state machine. So from the state machine we call this get transition count. So again, this function is of the state machine. So here, instead of getting the transition, so instead of getting the get transition, first we get the count of how many transitions we have. So in this transition, we know we have 9 transitions. So we get the transition count by calling this. So this returns how many transitions we have. So once we have the total number of transitions, then we iterate through all the transitions. So once we have the total transition count, then we use a for loop to iterate through all those transitions. And for each of the index number, we get the from node again by calling the get transition from. This function is again inside the state machine. We also get the to node. So this will return like for the first transition, the transition starts from 0. So the from node will be start, and the to node will be inactive for the 0th transition. So then we just print the state index, so like the transition index of this, and the from node is this, and the to node is this. So this actually gets the value of each of those transitions. So once we have the index values, then we can easily try to change these properties. So this feels like a kind of tricky, but this is how it works. And these functions are all built in the state machine, so we just used that functions. So alright, let's copy this print all transition, and inside the ready, let's just call this print all transition, and let's try to run the scene. So now let's quit this, and here you'll see that we have printed all of these transitions. So basically now here we need to change the transition of this one. So we go from de-equip bow to active. So let's select the output, and here we go from de-equip bow to active. So I can't zoom in. Okay, so we go from de-equip bow, that's over here, to active for the transition index 6. All right, so once we get the transition index, let's so once we get the transition index, we can try to change these values of that transition. So let's create one more function. Let's call it as set xfade time transition, and here we get the transition index that will be of type integer. Then we get our switch mode that again will be of type integer, and I will tell you why the switch mode, and we get this transition index later on, but just write this one as it is. So once we get both of these, let's also create a rough comment. So 6 index is for bow to active state. All right, so now let's zoom in a bit little. Okay, so here we can easily get the transition by calling tree root get transition function, and here we will pass the index value of that particular transition, and once we get the transition we can call the switch mode, and we can set the value of that switch mode. So now where do we get the transition index? Well, this is instead of passing, or I mean like instead of rough coding it as 6, we can pass the index value, so in future it may help, but you can hard code it as a 6, no issues. So we'll just pass that one, and then there comes this switch mode. So why the switch mode needs to be an integer? Because here these values are kind of strings, and why this is an integer? So the reason is, again, if we open up our animation node state machine transition here, so let's select the switch mode. So whenever we try to set our switch mode, this function asks for a value, and the value, it should be of kind switch mode. So again, here if you open up that switch mode section, then you will see that for immediate the value should be 0, for sync it should be 1. So it's not a kind of string that we need to set. Here we need to set these kind of integers. So for 0 it's immediate, sync 1, at end 2. So again we can just roughly comment it as 0 immediate, 1 for sync, and 2 for I think, yes, at end. Okay, so if you want to change it to immediate, then we'll pass the switch mode as 0, for sync it's 1, and for at end it's 2. All right, so just to set this transition, we do a lot of drama over here, and yes, this is how it works. So all right, let's copy this function name, and now in this root script, so if we are not in an active state, then we just call this change state function, and that's fine. But what if we were in inactive state? Only then we need to trigger that transition value that we just set now. So if we are in the aim state, then rather than triggering the transition values, we need to do some other process. So again, I will explain what process we need to do, but now here comes the condition of two different states. So either we can be in the inactive state, or we can be in the active state. So based on the states, again, we need to trigger some logics. So for that, let's create one more function. So I think this is gonna be the last function, I guess. So let's just write set transition time, and here first we need to get the last state that's equal to, I think rather than getting the limbo state, we just created a function. let's just search for get previous active state. So yes, so we get the name of that. So let's call this function get previous state, and here if there was no last state, that means we need to return. So this is an extra condition to avoid some glitches. So whenever our player is trying to fall and then he suddenly enters the lasers, or the laser starts to hit whenever there was no previous active state. So at that time, so rather than triggering the error, so we just return it. And then if we match our last state to some values, then we need to return some functions, or we need to trigger some functions. So all right, so if the last state that we came from to the active state was, let's say, inactive, at that time we need to call some block of code. Or else if we came from our aim state, then again we need to call some block of code. So here if we are from the inactive state, then yes, we need to trigger this function that basically sets these values. So let's here call animation tree set xfade transition, and the transition index was 1. So then we need to change its value to immediate. So for immediate, I think it was 0. So we pass here 0, and once we set both of these values, we can just return. All right, so now once we set these transition values, we'll go to our active state, and let's imagine one more use case that we were in this inactive state and suddenly the laser hits our player. Then we go to our active state and we change this state before actually going to active state. So once we change this state, we will be in the active state whenever the laser hits, and that's fine. But what if again we go back to inactive state and again we try to go back to active state? At that time we don't need this transition to be same as immediate, because we need to reset this transition, because this is how the complete graph is. So once we change this value, again we need to reset its to default value after the transition. So to reset these values, instead of writing it in the active state, we'll write it in the inactive state. So now let's say, now in short, if we are in inactive, laser hits, we change these values, we travel to active, and again whenever we travel to inactive, we just reset these values. So this was a short explanation. So let's go to our inactive state, and here we just call agent animation tree, set the index value of 6th transition to at end. So if I'm not wrong, then the 2 is at end. All right, so yes, this will reset it, that's fine again. So then we just return. But what if we were in the aim? So let's say we had our arrow drawn and the laser tries to hit. So at that time we need to shoot our arrow, and then the player can enter the reaction state. So we need to trigger the shooting mechanism, because the shooting mechanism was triggered from this playing the release arrow animation. And similar to this, we had the whole animation of shooting the arrow and then it travels to this active state. Okay, that's again in this, but here the problem is again same. So instead of playing the release arrow animation, we need the sudden switch. So for sudden switch, we can just call our bow control dot shoot function. So this will if our player is having the arrow, then whenever the laser tries to hit, we'll just suddenly release the arrow. So we call this function. So this function was basically again called from this timeline. So again, this timeline will not run because we need a sudden switch. So instead of calling from the timeline, we just call it manually, and once we call this, we need to also stop this one shot. So in the previous case, we needed to set these values, but now we need to stop this. So because this is one shot and we can't change any of the transitions, so to stop this one shot, I think we already wrote a function. So let's search for one shot. So this is one shot active, and then we have this one shot abort. So we can call this abort function. So instead of playing the complete release animation, it suddenly stops playing the aim and then it enters to the active state. So after playing the shoot, we can just call this set one shot abort, and we need to pass our one shot. This is of the animation tree. All right, and after that we can just return. So now let's call this set transition here. So if our state is a different active state, then we need to set this transition. And now there comes one more issue, and that's basically equipping and de-equipping the bow. So again, if you remember, then the show and hide function was triggered from this animation player. So if this animation is not played, then the keyframe of show or hide bow will not be triggering. So again, to overcome that, so if we were in a different state, then we can just create if our bow is not visible, then we can just set it to be visible. So that's it for this transition. So if you feel like again a lot of stuff has been gone, then just let me give you a quick summary. So if we were in a different state and if our bow is not visible, then we just set our bow to be visible, then we change the state, and now whenever we try to change the state, maybe we were in the inactive state, or let's say we were in the aim state, at that time we need to trigger some of the logics. So that's basically if we were in the inactive state, then we change this transition value to immediate, so that instead of playing this whole animation, we just suddenly switch. So that's over here. And if we were in the aim state, then we try to shoot the arrow that our player already has equipped, and once the arrow has been shot, we can just set our one shot to abort, so that we can suddenly switch to our active state, and then we can start playing the react animation. So this is what the complete summary is. Now let's try to run. I think it should work fine now. Yes, it's working. Let's go to our inactive state again. Let's try. Yes, it's working fine. So again, you can see that the transition is reset. So instead of sudden switch at a different point, like now the player is not hitting the lasers, but whenever we try to switch, it's working fine. So most of the conditions are now fulfilling, and there is one last point that I need to say. Sometimes what happens is, like in the aim state, let's say we release our left click or right click, and I don't know why, but sometimes whenever we try to release, we actually play our release animation. Yes, that's perfect. And whenever we play the release animation, the animation tree has this signal that's basically connected over here. Whenever we play the release animation, we need to change our state to a different one, and I don't know why exactly, but changing this state, it gets a problem where this function is not triggered. I think maybe that's because we have used these edit filters option. So some edit filters option. So I think that's because only the player's upper body animation is playing and the lower one is not playing. So maybe that's the reason why the complete animation is not finished and this is not caught. I don't know what exactly the reason is, but I just only know that whenever we try to release an arrow, this condition is not triggered. So if this condition is not triggered, then we don't enter our active state, and whenever we don't enter our active state, we can't again try to do anything. Like, we can't even try to dodge, we can't even shoot any arrows, and the player is kind of stuck between the two states. So inside the code, we are actually like inside these limbo HSM, we will be actually in this limbo state machine, but while playing the animation, we go inside this active state, and there is a mismatch between both of these states. So again, I can't make a complete drawing or what's happening behind the hood or what's not, because this animation tree doesn't call this function. So the animation tree doesn't call this function, and I don't know why I don't know what exactly to do this, because this should be called, and maybe Godot has a problem or the graph has a problem, like because of these edit filters it has a problem. But anyways, the problem is now ours and we need to solve that. So what we can cleverly do is, if we enter our aim state, then here at this point, what it basically checks is if we have just released our left click or right click. So we will create one more if condition that will only trigger that if we have not either been pressing left click or right click. So let me just show you. So let's say we don't press left click or we don't press right click. So the buttons both left and right are not pressed inside this aim. So the complete the concept of this aim state is like, we need to release our left click or right click. That means that whenever we don't press any of the keys inside our aim state, so if we are present in our aim state and we don't press any of the keys, that means that there was some glitch that happened during the transition. So during the transition from this to this, so we were currently in our aim state in this limbo HSM, but we somehow traveled to our active state. So at that time we need to change our state manually, because this is the block of code we can actually trigger the state change manually. Okay, so how do we even get to know that there is a mismatch? So for that, first we will try to get the node. So let's say the node is active in our case, but the state that we'll be having is the aim. So let me just show you. Let's go to our character body. So we'll come down, and here we'll create a function. So this will be hard reset state, and remember that this is very dangerous function because this can change the states manually. So calling this function inside anywhere from the script can break the behavior of your code. So don't call this function whenever you want. So we'll be using this function to change the state manually, so that's why we just renamed it as hard reset our state. And here first we'll get like which node we are currently in. So we need to get our node. So again we need to get like which node we are currently in. If we are in the active or inside our animation tree, first we need to get our current node. So for that, let's go jump back to our animation tree, and here let's create a function get current running node, and this will get the playback from our graph. And here we can just return our playback, get current node. So again, this function is from this state machine. So from the state machine playback, so like we exactly know like which node is active. So if we are in this node, then this will return this active node, or if we are in this, then it returns the inactive. So first we get our current running node from our animation tree. So we get our current running node and then try to check our node to which node we are in. So if we are in the active, so yes, we will be in the active. So at that time we can just change our state from our current state. So current state again is a function that we created above. So this will return our active state. So we get our current state, and the event name we call it as to active. So we go from our current state to active whenever our node matches to this node. So we can call this hard reset state from our aim. So this is a function of agent. All right, so again, let me just give you what exactly we do. So first we'll check if left click or right click is not pressed in our aim state, and the aim state is mainly responsible to hold the arrow. So let's say that we are in the aim state and we don't have pressed any of the keys. That means that, hey, what we are doing in our aim state, we need to travel to our active state, and that's what we actually do here. So this piece of code only runs whenever we are in the aim state and we did not go back to active state. So at that time we just call this hard reset function. So this condition will only run that whenever the animation tree fails. So at that time we hard reset our state. And so in the hard reset, what you basically do is, like, first we get our running node. So we'll just say which node we are in, and we'll be in the active. So again, we don't have a different aim node, so we'll be in the active. That means, yes, we have some mismatch. We are in the active state of our animation tree, but while in the limbo HSM we are in the aim state. That means, yes, we do have a mismatch. So at that time we just match to which state we are in. So if the running node of the animation tree was active, at that time we hard reset our state by calling the change state function, and we get our current state, and then we pass the event that we need to pass. So this is how we reset the state, and this is how the complete controller will be working. Alright, so now let's run. I think this time we can just go to project settings, under display we can change it to full screen, and let's try to play. You can increase the arrow speed if you wish, but I think this is good, and most of the stuff are working fine. And if you get some kind of errors, then I think I have explained a lot detailed for this complete series, so you may now try to figure the solutions if you find any minor bugs, but I don't think there are any of the major bugs. So if I find any major bug, then I'll sure try to comment it in the comments. That will be pinned again. And yes, most of the stuff are working. So now it's time to see all the scripts that we have made. Now let's see what all progress we made in this video. So we built a crosshair with a proper controller, added realistic head reactions, and then we also added a hip reaction for our shooting alignment, implemented environmental reactions, and finally fixed some bugs. Before we wrap up, if you enjoyed this video, then don't forget to hit like, drop a comment, and also subscribe for more future content. And if you'd like to go with an extra mile in supporting me, then you can just grab the potato card membership on my itch.io for just 1 USD. Every bit of this support really helps me for keep me creating more stuff and improving for you guys. Thanks for watching, and I'll see you in the next one.